Hello students, welcome to Learner's Planet, Theory Session 3 of Metals and Non-Metals. In our previous session, we discussed about the physical properties and chemical properties of metals, that is their reaction with oxygen. In this session, we will be discussing about few more reactions of metals. Let's first take up the property of oxides formed by metals. So here students, they generally form basic oxides. I told you that when these metal oxides are dissolved in water, they form what? Base. So reaction of metal oxide with water. Here is an example of sodium oxide. This reacts with water and forms what, children? This is sodium hydroxide. So this is sodium hydroxide. What is sodium hydroxide? It is a base or an acid? It is a base. Magnesium oxide reacts with water, giving what, children? Magnesium hydroxide. You will not say it as magnesium dihydroxide. This is what? This is magnesium hydroxide. Now I told you that metals, they form basic oxides, but there are certain metals like aluminium, like zinc, lead, they all form amphoteric oxides. Like aluminium oxide is an amphoteric oxide. That is, they react with both acids as well as bases, producing what? Salt and water. Like, let's take the reaction with acid. Reaction with acid. Aluminium oxide reacts with hydrochloric acid, forming what, children? Aluminium chloride. That is a salt and water. So this is reacting with an acid. Now let's take up its reaction with a base. Reaction of aluminium oxide with a base. Aluminium oxide reacts with sodium hydroxide. It is a base. And it is forming what, children? Sodium aluminate, that is a salt and water. So this aluminium oxide is reacting with acid as well as a base and forming what, children? It is forming salt and water. That is why it is an amphoteric oxide. The same is the case with zinc. Zinc reacts with acid. I'll write the reaction here. That is, zinc oxide reacts with an acid, children. That is, let's take up twice of HCl, the simplest one. And what it would be forming? It would be forming a salt. Right? Can you tell me the formula of salt it will be forming? It will be forming ZnCl2 plus of H2O. What is it, children? This is zinc chloride and salt, that is the salts and water. The zinc oxide also reacts with a base, NaOH, and it forms NaZnO2 and water. So what is a salt here, children? This is sodium zincate. Now remember, zinc in sodium zincate, that is NaZnO2, is present in the form of ZnO2 minus ion. Right? That is the negative part of that molecule. that is your NaZnO2 will dissociate to give what children? Na plus ZnO2 minus. Remember this, okay? The same is the case with the lead. Lead oxide, that is PbO, will react with, let's take another acid, H2SO4, and it forms what? Plumbic sulfate or PbSO4, plumbous sulfate, and H2O. This is also called as lead sulfate. And if I am treating this lead oxide with sodium hydroxide, what it would be? PbO plus NaOH. It will form NaPbO2 plus of H2O. You need to balance this equation. Okay, this is an unbalanced equation. You try to balance it. This is what? This is sodium. The name of the cation comes first. Plumbate. Plumbate. Right, children? So, always a metal oxide reacts with the metal oxide which reacts with acid as well as base is called as what? Amphoteric oxide. Clear? Now let's move to our next property, that is of oxides. Yeah, there is one more reaction written over here, that is reaction of aluminium oxide with water. How is it behaving in water? It is a metal oxide, so it should be basic in nature, right? Now, here aluminium oxide, reacts with water, giving what? Aluminium hydroxide. Now, this aluminium hydroxide, if it is dissociated, what all are the ions it is going to give? Aluminium hydroxide. Just try to find out what type of ion it is going to give. It is going to give what? Al3 plus ions and 3 OH minus ions. Right? Why bases have got basic property? Because of these hydroxide ions. Now let's move to its other properties, that is, there is reaction with hydrogen. Metals generally do not react with hydrogen as they form electropositive ions by losing electrons. That is not the criteria. Read the other point, that is, hydrogen also forms electropositive ion by losing electrons. You know, children, both metals like this sodium, like potassium, like magnesium, other metals, what are they forming? They are losing electrons, right? That is a typical characteristic of a metal. That what a metal does is, a metal loses an electron, and what it forms, children? It forms a cation, right? So this is metal. This, what it is doing is, it is losing an electron and it is forming M plus ion plus of an electron. Now your hydrogen also does the same thing. That is, your hydrogen atom, what it does, this exists as what? I have always told you, this exists as H2. Now what it will do, children? This will also lose electron. Okay, and it will form what type of ion? Twice of H plus of 2 electrons. Now how can they react? Both metals and hydrogen, they are forming electropositive ion. Now tell me, can two electropositive ion be together to form a compound? No, there will be positive charge and positive charge. And what it will do? The compound will break or the compound cannot be formed. Let's take up our next point, that is only few reactive metals like sodium, potassium, calcium and magnesium react with hydrogen forming metal hydrides. Because the sodium, potassium, calcium, they are more electropositive than hydrogen. So they are reacting with hydrogen forming hydrides. Like in metal hydride, hydrogen is present in the form of a negative ion. So in metals like sodium, potassium, which are very reactive, and what they do is they lose electron, and what hydrogen does is it gains electrons. Let's see its example. That is sodium with hydrogen forms sodium hydride. Now if I write these elements here, that is elements of first group. What are they? They are hydrogen, lithium, sodium, potassium, rubidium and cesium. Now as we are moving down the group, so when we are moving from top to bottom, what is happening, children? The tendency to lose electron increases. Tendency to lose electron increases. So which will have more tendency to lose electron? Hydrogen or sodium? Sodium, right? Because it is lying down the group. Likewise is the case with calcium also. Calcium is also more electropositive than hydrogen. Ca is more electropositive than hydrogen. So what it can do is it can lose electrons to hydrogen and form CaH2. So in sodium hydride, what is the charge on hydrogen? -1. In calcium hydride, what is the charge? -1. In calcium it is +2. Okay. So if I write the charge on calcium hydride, so it is Ca2 plus of 2H minus. Clear, children? So in metal hydrides, hydrogen is present as a negative ion. Now let's take up few other reactions, that is the reaction with water. Reaction of metals with water. Metals react with water to form a metal hydroxide or metal oxide and hydrogen gas. That is, your metal plus water gives a metal hydroxide and hydrogen gas. Potassium and sodium react vigorously with water, evolving large amount of heat. Due to the heat produced, hydrogen gas evolved during reaction catches fire. That is, your sodium metal is reacting with water, producing sodium hydroxide, hydrogen and large amount of heat. Now children, the reactivity of metal the reactivity of metal with water also depends upon the nature of the metal. which is if it is more reactive, like sodium, heat is evolved. There are certain metals which react with cold water. There are certain metals which react with warm water. There are certain metals which react with steam. So based on their reactions, the metals can be grouped as less reactive, reactive and more reactive. Let's take up our next metal, that is your calcium here. Calcium reacts with cold water, fine. Sodium and potassium were also reacting with cold water, forming calcium hydroxide. They were forming sodium hydroxide and potassium hydroxide and hydrogen gas. The products are the same. That is, they are salts and hydrogen gas. Now in this case, heat is not evolved. Remember this, children, heat is not evolved here. It means what all are more reactive? Sodium. So can I write here that sodium or potassium are more reactive than calcium? So this is the reactivity. So calcium is reacting with cold water, but heat is not evolved. Let's take up another metal, magnesium. Magnesium is again, magnesium reacts with hot water. It is not reacting with cold water. With what it is reacting, children? Hot water. And what it is forming? Magnesium hydroxide and hydrogen gas. So, magnesium reacts with hot water, forming magnesium hydroxide aqueous and hydrogen gas. So it is further less reactive than calcium. I can write here calcium is more reactive than magnesium. With what? This is reactivity with water. Now let's take a few more metals. There is reaction of metals with water. The metals are like aluminium, zinc, iron. They all react with steam. And what they form, children? They form their oxides and hydrogen gas. Rest of the metals, that is your sodium, potassium, calcium, magnesium, they were forming what all products? They were forming respective hydroxides and hydrogen, right? But metals like aluminium, zinc, iron, they are forming what? They are forming their respective oxides. One of the reaction I have written here for you, it is iron reacts with steam. It is not reacting with water and forming what? Fe3O4, iron oxide and 4 hydrogen. In this iron oxide, in this Fe3O4, children, O4, iron exists. Iron is present as in +2 state also, that is Fe2 plus, as well as in Fe3 plus state. So Fe3O4 is also called as iron 2,3 oxide. Right, children? Let's take up the example of aluminium, that is aluminium solid reacts with water and it forms what? It is not forming aluminium hydroxide. It is forming aluminium oxide, Al2O3 plus hydrogen gas. This is looking like mercury. I'll just correct it. So plus it would be forming what, children? It would be forming your hydrogen gas, that is H2 gas. Now in this case, let's balance this. right? I'll make it thrice of H2O and it will form thrice of H2. So rest all the metals are forming oxides. The least reactive metals like your copper, silver and gold, they are not giving any reaction with water. Let's take up our next reactions, that is reaction of metals with salt solutions. This is a salt solution. More reactive metals can displace less reactive metal from their oxide, chloride or sulfate in solution or their molten state. It means that water oxide or sulfate you are taking, and if you are treating it with a more reactive metal, it is going to displace it. Like, for example, if metal A displaces metal B from its solution, it is more reactive than B. Metal A plus salt solution of B. So what is it doing? What is A doing? It is removing B from its salt solution and taking its place, that is salt solution of A and metal B. For example, iron reacts with copper sulfate, giving you what? What iron is doing, children? It is removing this copper. It is displacing this copper and is forming iron 2 sulfate and copper. That is Fe solid plus CuSO4 blue aqueous which reacts with FeSO4 and copper. Here also, see children, the color is indicated. As soon as the copper sulfate decolorizes, what is to be assumed is that the reaction has been completed. Let's pick up few more examples. Reaction between zinc and copper sulfate solution. Copper sulfate aqueous, it is blue color again. Zinc solid, it is forming what? Zinc sulfate. What is zinc doing, children? Zinc is displacing copper from its solution. So which will be more reactive, zinc or copper? Zinc. So it is forming zinc sulfate and copper. So zinc is more reactive than copper. Likewise, it's the same, the reaction of iron with copper sulfate. Iron is more reactive. So children, by treating your metal with any salt solution, you can just make out which metal is more reactive, right? Now these elements are arranged in reactivity series, right? Now what is this reactivity series? Let's check out. It is the reactivity series. It is the arrangement of metals in a vertical column in the order of decreasing reactivities is called reactivity series of metals. Like how they are arranged, children? Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. So which is the most reactive? Potassium. Then is your sodium. Now if I am taking salt solution of calcium or salt solution of magnesium, say I am here taking MgCl2 and I am reacting this with sodium. So here what is more reactive, children? Sodium is more reactive. So what it will do? Sodium will displace magnesium and it will form what? What will be formed? NaCl plus Mg solid. So this is the reactivity series. So the metals which are, or the elements which are lying below the reactivity or in the lower position in the reactivity series can displace the upper elements from their salt solution. Now in this case, there is also that the elements lying above hydrogen in the reactivity series evolve or release hydrogen gas from acids or from water. I can put a note here that elements above hydrogen in the reactivity series release H2 gas from where? From acids. Remember this point. This is very important. Those elements which are present above hydrogen in this reactivity series, they release what? Hydrogen gas from their acids. And those elements which are present below hydrogen in the reactivity series do not release hydrogen. My point is clear? So, you don't think that you need to mug up the series. You just remember first 4 elements, that is potassium, sodium, calcium, magnesium and aluminium. That's it. And the last one, that is copper, mercury, silver and gold. These are the least reactive. They will not release hydrogen from acids or from water. These are more reactive. They will release hydrogen from acids and water with large amount of heat. Right? Till magnesium. These will release hydrogen but they will not release heat. Now children, we'll put a note here. That will be better. That is, say your metals like sodium, potassium, calcium, magnesium. Right? What they do is they release hydrogen gas, they release H2 gas, H2 from acids or water, and also they release what? Heat. Okay? Metals like aluminium, zinc, iron, what they do? They also release H2 from acids or water, but they do not release heat. They do not give heat. Whereas metals like copper, mercury, silver and gold, what they do? They do not release hydrogen from acids or water. So you remember this much thing only. Okay students? So the metals above are more reactive, release hydrogen gas with lots of energy. Below them release hydrogen but no energy is evolved. And below hydrogen they do not release hydrogen gas from acids. So now I'll conclude this session. You just try to practice the chemical reactions we did. Just go through the chemical equations and properties. In our next session, we will be discussing about few more properties of metals, few more reactions, and about the properties of non-metals.